Today we're doing section 5.3 part 1. 5.3 part 2 is next. I'd recommend watching them both at one time. The lesson I'm assigning has all of the classwork together. I didn't split it up into the separate videos. So today we're going to learn how to solve quadratic equations by graphing and factoring. Then we're going to learn how to write quadratic functions given the roots. We have 4 vocabulary words: the zero of a function, the root of an equation, binomials, and trinomials. The zero of a function is the value of the input, which is x, that makes the output, f of x or y, equals 0. So you plug in an x, do some calculations, your output is 0. The zeros of a function are the x-intercepts. So if you see where the x-intercepts are where it crosses the x-axis, these are your x-coordinates, which give you the zeros. Okay, if I plugged in the value of this, the x, the number, x equals a number, if I plug that into the equation f of x, I would get an answer of 0. So I just opened up my calculator and typed in, I hit the y equals button and typed in x squared minus 6x plus 8. Okay, then I'm going to hit second table and look where I want to know what the value of x is when y equals 0. So if I look, that's one of them. And you can always look at your graph. If I push the graph button, okay, you can see that your parabola is over here. So you know where to look for x equals 4, x equals 2, and where those x's are, y equals 0. Okay, so those are actually your zeros. The zeros are 2 and 4. That is your answer. Okay, find the zeros of the function using a graph and a table on your calculator. Again, I'm going to hit y equals and type in negative x squared minus 2x plus 3. I'm going to hit graph so I can see it. And it looks like this one goes roughly like this, so I know where to look. Okay, that x is going to be negative, and that x is going to be positive. So I'm going to hit second table and look at the table in my calculator. And we're looking for y is 0. So x is 1, y is 0. Now let's go negative. X is negative 3, y is 0. So the zeros are 1, don't do that, hold on. We don't want it to look like an ordered pair. The zeros are 1 and negative 3. You can also find the zeros using algebra. We're going to set our function, because remember our function looks like this. We're going to set equals, let's just say, ax squared plus bx plus c. We're going to set that equal to 0. Okay, the solution to the quadratic equation in standard form are the roots. The roots of an equation are the values of the variable that make the equation true. So when we say we're making the equation true, we're making it equal to 0. Okay, so the values of x that give you 0 are called the roots. Functions have zeros or x-intercepts. Equations have solutions or roots. It's just a different terminology, but basically or essentially the same thing. So we're going to find the zeros of this function by factoring. First I'm going to set it equal to 0. And factoring is going to take some practice because it's been a while since we've done it. Okay, I'm going to take 2 sets of parentheses. If you remember, x in the beginning. Okay, I have a negative here, and a negative here. That means I need different signs. Okay? And here we look at factors that when I multiply them together give me 12, but the difference is 4. So 3 times 4, 2 times 6, 1 times 12. Okay? So if I multiply 2 times 6, I get 12. And if I take the difference of 2 and 6, I get negative 4. I get 4. So if we do 2 times negative 6, we get 12. And add 2 and negative 6, it's negative 4. So I'm going to put my negative 6 there, my 2 there. Makes sense? Now let's check this, make sure we did it right. I'm going to FOIL it. First, outer, inner, last. First, x squared, outer, negative 6x, inner, positive 2x, last, negative 12. X squared minus 4x minus 12. Okay, we did it right. Now, hopefully I have enough room to finish. We need to take each set of parentheses when we factored it and set them equal to 0 and solve for x. Okay, add 2 to both sides, so we get subtract 2 from both sides, we get x equals negative 2. Add 6 to both sides, we get x equals 6. These are your roots of the equation. Okay, if I plug either of those numbers back into the function, I'm going to get 0. Let's try another one. Find the zeros of the function by factoring. Okay, first I'm going to set this equal to 0. Okay, this one I don't have to set it up into 2 sets of parentheses. Okay, I can factor my greatest common factor out first. What is the biggest number and letter that is common between both of these terms? Okay, I can take a 3x out of both terms. Take a 3x out of the first term, I'm left with an x. Take the 3x out of the second term, I'm left with a 6. Now you set each one of these pieces equal to 0 and solve. 3x equals 0 and x plus 6 equals 0. So x equals 0, x equals negative 6. These are your roots of the equation. Okay, you try this one. You're going to have to factor it. Okay, so set it up into 2 sets of parentheses and solve. Okay, there we go. I factored the equation. Okay, I looked at factors that multiply together to give me 6, and the difference is 5. Just like before, I have a negative here and a negative here. This means I need different signs. This means that my biggest number is negative. Okay? You try another one, push pause. These are always easier because you can factor out your greatest common factor and you don't have to, factor the big equation into 2 sets of parentheses. So we have the roots of our equation. Okay, a few word problems. Let's read through this. Any object that is thrown or launched into the air, such as a baseball, basketball, or soccer ball, is a projectile. I think a football counts too. The general function that approximates the height, h, in feet of a projectile on Earth after t seconds is given. Okay, this is an equation that we didn't make up. Scientists actually developed this equation, and this approximates the height of a projectile. So if someone throws, let's say a football, it goes like this. Okay? So that approximates the height in feet after t seconds is given. So this is time. You throw the football. As time goes, it goes up and it goes down. Note this model has limitations because it doesn't account for air resistance, wind, and other real-world factors. There's friction out there. This is a ideal situation, taking away any limitations, which is really not accurate, but we need an equation to mess with. All right, a golf ball is hit from ground level with an initial vertical velocity of 80 feet per second. I'm going to write that equation that's on that last slide because it's the one that we're going to use for everything. Okay, V0 is initial velocity. H0 is initial height. Okay, what's the initial height when you hit a golf ball off the ground? 0. Okay, the initial velocity was given at 80, and that's given. Okay, now we're going to solve it. Okay, set that equal to 0 and solve it. What's cool is that 0 at the end helps us solve it much, much easier. I'm going to take out a negative 16t. I'm going to factor it. It gives me t minus 5. 80 divided by 16 is 5. And solve. Negative 16t equals 0. T minus 5 equals 0. T equals 0 and t equals 5. So how many seconds? After how many seconds will the ball hit the ground? So that's the beginning, that's the end. And if you looked at the graph, it would look like this. This would be 5, that is 0. Okay? Okay, you try this one. A football is kicked from ground level with an initial vertical velocity of 48 feet per second. How long is the ball in the air? I'm going to write down that equation that we're going to use for everything. Initial velocity plus initial height. Okay, push pause and please try it. So the ball is in the air for 3 seconds. Okay, so that means your graph looks like this. 0, 3. Okay, and it went that high. Good job.